about trig equations. And trig equations are basically a three-step process. So if I give you a basic trig equation, something like this, sine x equals 0.7. Now, if I wanted to visualize what this looked like on a trig graph, and I'm just going to draw one for you now, trig graphs look like this, and they go in increments of 90, 180, 270. I want to know from the class, what's the highest value that a sine curve can get to? What's the highest value we can get up to? What's the lowest value we can get to? Tell me in the chat or raise your hand. What's the highest value that sine can get to? What's the lowest value? Oh, I mean, in terms of the y values, sorry. Yep. So the highest value that it can get to is 1. So I'm going to put a 1 there. And the lowest value it can get to is -1. Now, that just gives you a visual interpretation of the sine curve. One full period is 360, but this can obviously keep on going if I kept drawing it. Now, that's the sine curve that I think a lot of you have seen before. But now, how does this connect to this equation here? Well, if you imagine, where is 0.7 on the y-axis? Well, if that's about halfway, 0.7 would be about here. Give me a thumbs up if you understand that 0.7 would be about there on the y-axis. Okay, now, if you imagine 0.7 on the y-axis, 0.7 on the y-axis is always going to be in line with that straight line. Okay, so if you imagine it going through, and so when we try to solve a trig equation, we're basically saying, where does this particular trig graph cut into this constant function? And the answer for this thing would be something over here and something over here. Now, there would be more solutions later on, but initially, it looks to me like the two solutions, one would be between 0 and 90, the other one is going to be between 90 and 180. Give me a thumbs up if this visual interpretation of the trig equation makes sense to you. Like the graph is equal to 0.7 somewhere over here on the x input and somewhere over here on the x input. So what we need is we need a method for figuring out what are the answers here. Like we'll call that answer number 1, x1, and we'll call this answer number 2, x2. Now, if you don't understand, that's not a problem. Let me teach you this wonderful process. So step number 1 is we are going to decide in what quadrants, okay, is sine positive. Now, tell me which quadrants is sine going to be positive. You can even use your cast diagram. So sine is going to be positive in quadrant 1 and quadrant 2. Okay, now, if we think about the angles in quadrant 1, I'm going to call this just the reference angle that we find, or you can call it theta if you like. And then I'm going to call the angles in quadrant 2 as 180 minus the reference angle, or 180 minus theta. Now, for now, that might seem a bit strange, but just think back to our lessons on the cast diagram, how it's like everything in the different quadrants. Sometimes I think I said x, 180 minus x, 180 plus x. So I'm just using this idea, except instead of writing x, I'm writing ref for reference angle. Now, let's go and find what that reference angle is. So you put into your calculator, shift sine 0.7. So shift, and in your calculator, it then comes out as inverse sine. So I want you to put that into your calculator, and then I want you to tell me what you get for that. So number 2, we'll say reference angle equals shift sine 0.7. And what do you get as the answer in your calculator? Okay, we get 44.43 is my reference angle. So now step 1 was identifying the quadrants. Step 2 was finding the reference angle. Step 3 is going to be to write out the answers. But because there's an answer in quadrant 1 and in quadrant 2, I'm going to make space for 2 answers. And in quadrant 1, the answer will be 44.43. Or in quadrant 2, it will be 180 minus 44.43. Now, why is my second quadrant's answer 180 minus 44.43? Who would like to put their hand up and tell me why my second answer is 180 minus 44.43? What's it connected to? Any ideas? What is that value going to be in your calculator? What's 180 minus 44.43? It's the rule of quadrant 2. Yes, Pilar, exactly. So we spoke about this at the beginning where we said quadrant 1 and quadrant 2. So what is my x values answer going to be? It's going to be 135.57. So if we look back to that original picture that I showed you at the top here, now you don't have to do this. This little graphing bit is just so you understand the big picture. The one answer is going to be 44.43, and then the other one is going to be the 135, which I'm struggling to fit in, which is over there. Now, these are the solutions to this equation for x between 0 and 360. So when x is between 0 and 360, then those are the answers. But trig equations repeat themselves, or trig solutions repeat themselves every 360 degrees because the period of the sine graph. So if your teacher asks for the general solution, all you do is you tack on a plus k times 360, plus k times 360, and you say where k is an integer. And all this is doing is it's taking into account the other solutions that are going to happen if the sine graph carries on going. Give me a thumbs up. I mean, I'm not expecting you to be perfect at this. We're still going to do lots of examples, but give me a thumbs up if you understand the 3-step process. Step 1, quadrants. So say quadrants, then it's reference angle, and then it's answer. Okay. Now, what I think we need is we need another one. We need another question to just help us get this. The good news is once you get it, it is easy peasy. So I'm going to make another question for you. I'm going to say, solve the trig equation when the cos of x equals 0.8. And I want you to find me the general solution. So find the general solution to the equation. And I want you to start with step 1, which is which quadrants are going to be relevant. Okay, off you go. See if you can do it using the logic that I've shown you. And maybe I should even leave the other question up on the board so you can see it a little bit. You don't need to draw a graph there. Like you can just, we're just focusing on the 3-step process. And then once you've got one of your answers after a while, you can just pop it in the chat. where would cos be positive? It would be positive in, so 360 minus the reference angle, and it would be, so it must be in those two quadrants. Now, what is my step 2? What is my reference angle? It looks to me like it would be 36.87. And then step 3 is we need an answer for quadrant 1 and for quadrant 4. I'll give you a bit more time to write those in. So why are we using 360 minus x? In this quadrant, the angles have the form 360 minus the reference angle, but some teachers will say that you can use just plus and minus, and that's fine too. So there's 2 ways you can get the answer. The one is to say plus or minus 36.87, or like I'm doing, you go 36.87 and a 360 minus 36.87. So Buklev, those answers are equivalent. I'm not going to go into why they're, well, it's just because they're 360 degrees apart, and that's it. And so I like focusing on the cast diagram, but both of the answers are correct in that way. Okay, so in this case, we're going to say x is 36.87 for quadrant 1, and then for quadrant 2, it's going to be that, which gives me 323.13. Now, if they said I only want the answer between 0 and 360, then I'm done. But they didn't. They said find the general solution, which means that the period of the cos graph is 360. And so to make this a general solution, I have to add that bit there. Ooh. So that is the 3-step process. I want a quick little vote. Thumbs up or happy faces if you followed that. Thumbs down if you didn't. And maybe like a meh in the middle face if you are feeling in the middle. Okay. All righty. So what I think we need to do before I move on to harder trig equations is I need to give you one where there's a negative. So I'm going to say to you, here is the 3rd question for the day. And this is going to be that the sine of x is equal to minus 0.3. Now, I want you to find the general solution, I'll call it GS, for this equation. But I want you to think about, maybe somebody can even help us, how do we handle when it's a negative? Maybe some of you can remember this from class. It's a little bit more sneaky when we are dealing with a negative. So I'm maybe wondering if someone, when sine is negative, how does the process work? I suppose step 1 is still the same. Maybe we should do this one together. Let's do one together and then one for you guys. So in which quadrants is sine negative? In which quadrants is sine negative? So if I look at the chat, people are saying quadrant 3 and quadrant 4, which means the format of our answer must be 180 plus the reference angle or 360 minus the reference angle. So we're in those 2 quadrants. Now here is the difference. When you have a negative, the fact that it's negative is taken care of already with the quadrants. So because you're in the correct quadrants, you don't need to worry about the negative in front of this. And when you are finding what your reference angle is, you ignore the negative. So you'll go inverse sine of just 0.3. You do not put negative 0.3. If you do it again, you've done it twice and it's going to mess up your answer. So I want to know, what is my reference angle for this particular question? Pop it in the chat. So you should be getting 17.46. And now I want you to work out my answers for me. What's the last step? So I know my answers are in 3 and in 4. So X is going to be it's going to be 180 plus 17.46, so 180 plus 17.46, or X is going to be 360 minus 17.46. That is going to give me 197.46, or X is 342.54. And because I wanted it to be a general solution, I have to add multiples of the period of the graph. And so that would be it. So the thing that I want to point out that catches students is when you deal with the negative in step 1, when you choose the correct quadrants, you are dealing with the negative. What that means is you need to ignore the negative in this part because you've already dealt with it. If you deal with it twice, it actually reverses it. So that's the main thing I wanted to test. And I want to give you one more question around this idea, and then I'm ready to move on to other types of equations. So I'll leave this one up. And then I'm going to say, can you solve for me the trig equation minus cos of x equals minus 0.6? And I want you to find the general solution. Okay, off we go. And I want you to use the same process we used before, but just adjust it slightly. And I'll leave the working on the yeah, so it just says K. So this thing over here is just a K, and it's saying K belongs to the integers. So the integers are like minus 1, 1, minus 1, 2, I mean, minus 2, minus 3, 3, 4, etc. What is your reference angle in this question? Topila, Morgan, Silvato have all, and I agree, they are going to be 53.13, but that's not an answer. It's simply the reference angle. To get the answer, I'll say step 3, my answers need to be in quadrant 2, and they need to be in quadrant 3. So let's see what we get. We get x is 180 minus 53.13, or x is 180 plus 53.13, which then what does that give me for x for my answers? $26.87 or 233.13, but it's a general solution. So because the period of the cos graph is 360, we add on that it can have answers that are multiples of 360, and then we tell my marker that that k is an element of the set of numbers called the integers. And their symbol looks a bit like the Zorro symbol, but it's a Z with an extra line. Okay, Lindo Kuchle, I see your hand is up. What can I do for you? What question do you have?
No, sir, I only wanted to say my answer for this question.
Oh, sorry, I'm going to come back to you in a moment. But how are you feeling so far? Do you feel like you've got this?
Yes, sir, I think I got this.
Awesome, 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 awesome.
Thank
Okay,
you.
well, tell you what, pleasure. Let us go and look. Take a screenshot now of this one. I want to do one more. I want to do a more spicy one before we have our break, but I'm very impressed by what I'm seeing, and I feel like the basic method has landed. So Taran has asked, why is quadrant 2 not plus 90? Sadiq, or Sadiqa, if you were using the vertical reduction formula, it would be 90 plus, but we tend to use the horizontal reduction formula unless there's a reason to use the vertical. So you'll see I'm always using either 180 or 360. Okay, let's go to a slightly harder one, but only slightly harder. And I want to ask us all to focus on question 2A. Now, before we even, I want to have a bit of a class brainstorm. So we're focusing on this question over here, and it says to determine the general solution for x in the following equations. And I want us to identify as a class what is different about the yellow equation compared to the ones that I've done so far. What is different? Okay, we have two trig expressions, is what Morgan has said. There's a cos and a sine. Who else notices anything different? We have a coefficient for sine. Yes, that is awesome to Matzo. So there's a 5 in front of the sine, which is important. If you had to compare the angle for cos, oh, wait, you're given the angle for cos. Now, what does it mean if you're given the angle? That's not a variable. So if you put the cos of 320 in your calculator, what do you get? Because it's not a variable, it's a constant. So who can tell me if you put cos of 320, what do you get in your calculator? Anyone else who has a... Okay, speak about 0.77. Now, what I'm going to do is, it is about 0.77, although I think there's some rounding off going on there. But if I wanted to make my life easier, I think I could divide both sides by 5, and then I'm going to get the cos of 320 divided by 5 equals that. Give me a thumbs up or a smiley face if you understand how I brought the 5 to the other side. And now this is a value that you have, that's a 0.77 divided by 5, but I'm just leaving it there for now. Okay, now, this is a number. This thing over here, cos of 320 is about 0.77. Then this thing over here is divided by 5, which I guess makes it about 0.15 or 0.6. I want you to try and solve this trig equation using the method I've shown you so far. Now remember, cos of 320 is a number, 5 is a number. This whole thing ends up being positive. So you're going to start by asking yourself, where is sine positive? And see if you can solve this trig equation. Okay, so we know it's going to be in quadrant 1, which will be my reference angle, or it'll be in quadrant 2, which is 180 minus my reference angle. Step 2, what is my reference angle? It's simply going to be the inverse sine of this whole thing. So there will be some slight rounding differences if you don't leave it like this, but if you go shift sine and then you go cos 320 over 5, what do you get for your reference angle? It should be somewhere around 8.6 or 8.8, depending on if you've used rounding. So I'm going to say approximately like 8.6 to 8.8. Let me just go with 8.7 for now, although that's not the correct rounding, but you get where we're going with this. And then step 3 is what quadrants are my answers in? It's quadrant 1 and quadrant 2. And so my answer has to be that x is 8.7 or x is 180 minus 8.7. And then because of what's that going to be? 171.3. And then to make it a general solution, we're going to say k times 360, where k is an element of the integers. Okay, now that what we did there was we made it a bit harder because we made the information a bit more vague. And when we come back after the break, we're going to look at how we can, I call it dressing up trig equations. We can dress it up to make it look more complicated. And then all we need to do is take that bit away and we're back to the method we were learning at the beginning. Okay. So I know that my brain needs a break. Morgan's asked, why do we add k times 360? Because Morgan, in the question, it said that we need to determine the general solution. And the general solution includes all the solutions. And because the sine graph repeats itself every 360, the answer here, 8.7 is an answer, but so is 368.7. And the k times 360 allows my answer to include those answers. Okay, so on our feet, I want us to all get up. I want us to turn on the cameras. I know that we need to take a moment to just breathe and just let our brains relax. You can't just work your brain into the ground and expect it to keep performing. So you need to do some repairs and maintenance. So let's take a deep breath in and hold. Oh, this feels so good. You are missing out if you are not breathing. Do one more. Oh, I feel like a new human being. Okay, shake out the arms to get some circulation. Shake out the legs. Let's do some small circles with our arms just to get shoulder blades turning and then going into some big circles. Then change your direction. So you're going backwards into small circles. And then shake out again. And then have your arms out and just twist a little bit to start with. And then as you feel you're relaxing, you'll feel your body turning even further. Yo, I'm clicking like a mouse here. Okay, shake out one more time. Then we want to get our heart rate up. So we are going to do some jumping jacks and we start in 3, 2, 1. Let's go. 2, 3, 6, 8, 9, 10, halfway. 12, 14, 15, 16, 17, 20. Woo! And I can feel that the oxygen and the blood flow has circulated around my body, which means my brain is going to treat me well. And let's just do one little Maths 24 question to make sure we don't lose our skills. Why don't you can you make 24 using those 4 numbers? And I'll even offer you a second one. Because it's been a while since we've done Maths 24. How do you make 24? Ooh, I can feel my heart. Boom, boom, boom. Okay, so Dika, 2 minus 2 is 0, plus 6 times 4 is 24. And Flutter also got that, which is awesome. So the red card is solved. Can you do the blue card? Can you do the blue card? I'll give you a little hint. If you go 4 minus 3, that's pretty helpful. 4 times 4 plus 5 plus 3. Oh, I think there's a better way. 4 times 4 is 16, plus 5 plus 3 does give you 24. And then another way is 5 times 4. Oh, yeah. Okay, you guys all got that way. My way was thinking of 4 minus 3 is 1, and then 5 plus 1 is 6. And then you've still got 1 4 left. So you go 6 times 4 is 24. Okay, nicely done, everyone. Okay, so in the second part of the lesson, let us go back to more dressed up trig equations. And I want you to start by doing, let's start by doing C. So you are going to do question C for me and see if you can solve that. And we can give each other help or tips in the chat, or someone can raise their hand if they want to ask a question. But for now, we're trying to solve the trig equation tan of x. So tan of x minus 1 is separate, over 2 equals minus 3. We're trying to solve that for its general solution. See what you can do. So what I'm noticing in the chat is lots of students are saying, I need to get the tan of x by itself to make this a bit easier. And I think that's a good idea. How do you get the tan of x? What inverse operations do you need to use? And then you can start your journey. Yes, Tegavatso, I would do that. I see Keisha has her hand raised. Can we unmute for Keisha?
Hi, sir.
Hey, how can I help?
So I wanted to answer the question. Is that fine?
Yeah, go ahead. Yeah, definitely.
All right. So since tan x minus 1 is over 2, we're going to take 2 to the other side. So it's going to be negative 3 times 2.
Okay, so you get negative 3 times 2, which is minus 6, eh? And then
Yes. And then tan x is equal to negative 6 plus 1.
Yep, because the minus 1, you add 1 to both sides, negative 6 plus 1.
Yes.
Really going to say,
And then
tan of x, what? What do I
is
get
equal
there?
to negative 5. Negative 5.
Perfect. Okay, so now you have got it back to what you were doing before. What's your next step after that?
I'm going to take tan x to the other side. So it's going to be the reciprocal of tan x
Yeah. So you're following the
times negative 5.
process. You're following that 3-step process that we were doing earlier on. Fantastic.
Yes.
Love it. I'm going to give someone else a chance to have a go at this next part, but thank you for your
Okay.
input.
You're welcome.
So where do we go next? We've got a nice helping hand there from Keisha. And what is a little bit special about tan? I don't know if you guys remember this from class, but tan doesn't have a period of 360. What's the period of the tan graph normally? So the period of the tan graph, I can see lots of students are saying this, is 180, which means we don't actually need to be in 2 quadrants. We only need to get the answer for 1 quadrant. And then if we go up, the period of 180 will gobble up the second solution. So in what quadrant is tan x negative? Because it says tan of x is minus 5. When is tan of x negative? Which quadrant? So you could use the second or the fourth, but because the period of the tan graph is 180, whatever answer you get in quadrant 2, you would just add 180 to get the next answer. So you don't actually have to find 2 answers. You only have to find 1 answer for a tan trig equation. And I'm going to go with the second quadrant because it seems the easiest. So it's 180 minus the reference angle. Step 2 is to find my reference angle, but remember, it's going to be, I must ignore the minus 5 and just go shift tan of 5. What's my reference angle going to be? So if we go shift tan of 5, what are we getting? I think we're going to get 78.7 if we round to 1 decimal place. Okay, third step. I only need the answer for quadrant number 2. What is my final answer going to be? So I'm going to go that x is equal to 180 minus 78.7, which is going to be 101.3, but I need it to be a general solution. So what am I going to add on to this? It's a general solution. And because the period of the graph is no longer 360, but 180, I should have a k times 180, where the k is an element of the integers. Now, we've now covered all three of the trig equations. We've also covered the slightly harder ones. Give me a thumbs up if you feel like you're good, thumbs down if you're not, and like a meh face if you're in the middle. So Flatter, why is theta, why is it times 180? Because the period of the tan function is 180, whereas the period of the sine and cos function is 360. So it's because that the period of the tan graph is different. If you think about what the tan graph looks like, now we're actually going to do trig graphs in the next lesson, but if you think about how often a tan graph repeats itself, it repeats itself every 180 degrees. And that's why there will be a period of k times 180. Okay, you guys start with this question over here, the one I'm going to put in green. And I'm actually just going to write it bigger on the side here. While I'm writing it, what do you notice is different about this trig equation? So you can put your hand up or you can put it in the chat, but I want you to just take a moment to notice what is different about this trig equation. Who has some ideas? So two terms on the left-hand side. Yep. So there's the 2 and this. What do you think we're going to do first to solve this trig equation? What do you think my first step will be? Yeah, so the 2 on the other side, like all equations, you try to get the cos variable term by itself. So all I'm going to do is I'm going to take the 2 to the other side. It becomes a minus. And now I get this answer, well, I get this equivalent equation. Now, in the original question, they were wanting the solutions between minus 180 and plus 180, but for now, I'm just going to stay with the general solution. Now, what is different here is that no longer is there just an x inside, there's a 2x minus 10. But the good news is there's only one little thing we have to do differently to handle this. So what was our first step? It was to find where cos is positive. So where is cos going to be positive? Let me know in the chat where you think cos is going to be positive. So all I'm doing is I'm extending the methods I've taught you in the first part to handle more, I call them more dressed up trig equations. But once you get them back to the same dress code as before, everything is fine. So cos is positive in this quadrant in this one, which would be whatever the reference angle is, or 360 minus the reference angle. Okay, exactly the same as before. Second step is to find the reference angle. Now, the good news is we are just going to ignore the more complicated thing here. Normally, it's just x, but in this case, it's more complicated. Who cares for now? We just go reference angle and we say inverse cos, and what do we get for that? Who can tell me my reference angle? So we are getting 57.52. Now, good news is we can go to step 3 what are the quadrants that are going to have my solutions? It's going to be quadrant number 1, and it's going to be quadrant number 4. Now, normally, when we go to this step, we would write x equals something. But because it was no longer just x inside the cos, what do you think I'm going to write to start over here? Am I going to write x, or what should I write instead? It's going to be 2x minus 10, because that is what is inside the cos function. And that is going to be equal to 57.52. Or we could say that 2x minus 10 equals, what could 2x minus 10 also equal? What could 2x minus 10 also equal? If we look at the method or process we've been following. Quadrant 1 was just 57.52, which was the reference angle. This would just be 360 minus 57.52. I want you to find me what is the value of x in quadrant 1 and what is the value of x in quadrant number 4. You have to do a bit more work. I suppose there would be an intermediate step where you go 67.52, and this would be 3760. That's going to be about 312, 313, something like that. Can someone just give me what is 360 minus 57.52 plus 10? I want to get 2x equals something, and I want it to be correct. That's going to be 312.48. Yeah. So we've got that. And then x is going to end up being, if we halve that. Now remember, we still have to include the general solution bit, but we should get 33.76, or x is 156.24. But if I want general solutions, the period, the period will be, now this is where I need to be careful. Oh, okay, hold on, wait. So what I need to do here is, okay, guys, I made a little bit of a mistake here. Let me include something here. Hold on. So what I need to do is, I should have done this at the very beginning. My apologies. So let me just reverse for a second. Everything is fine. So we had 2x minus 10 is equal to 57.52. So 57.52 plus, I should have gone k times 360 at that point. Or I should have written 2x minus 10 equals 360, okay, minus 57.52 plus k times 360. Now, if I don't do that, I'm going to end up making a silly mistake. Take a moment and see, do you understand the difference here? Do you understand the difference here between, you actually have to do it like this. You can't leave the k times 360 till later. You have to write this at the very beginning. So do you, give me a thumbs up if you followed me. Give me a thumbs down if you haven't followed me with this part. Okay, now, the reason you have to add this in now is that you need to divide the k times 360 by 2. So let's just keep going. So we go 2x equals 67.52 plus k times 360, or 2x equals 360 plus 10 minus 57.52 plus k times 360. And now, let me just get this to be, what was this? This was 312.48 plus k times 360. And remember, we actually need to have k is an element of the integers here. Now, why is Mr. Skitter making such a fuss out of all the k times 360s throughout? Well, at this last step, when I divide by 2, okay, I'm then going to get 156.24. But I also have to divide the 360 by 2. How much do I get when I go 360 divided by 2? I'm going to get k times 180. And that's why I had to go back and make sure that I wrote this in at the very beginning. Okay. Now, with this one over here, on this side, I'm going to get x is, oh, sorry, guys, I made a mistake here. This should be 67.52 divided by 2 should be, let's have a look. What should that be? That should be 33.76. And then on this side, you should have, what is 312.48 divided by 2? It's going to be 156.24 plus k times 180, and that would be the correct answer. Okay, now, that was a bit of a toughie, so I just want to zoom out for a second. Are you all with me on that? Are there any questions or comments before I move on to our final example? Meh, don't worry, you can rewatch this for Techo.